Welcome to this video lesson on proving trigonometric identities. In this video, we shall first go through some concepts around types of proofs, ideas of equivalence, and definitions of identities. We will then go through the strategies that one can use in the process of proving identities. Finally, we will go through some textbook examples before ending the introduction lesson. In mathematics, there are several kinds of proof, of which two are most relevant. The first kind of proof is by direct proof. As seen in this first example, the two expressions are equivalent and can be proved to be so by either factorizing the left-hand expression to obtain the right or expanding the right-hand expression to obtain the left. Both approaches are of equal difficulty. In a second example, however, to prove that the two expressions are equivalent, one may prefer to expand the right-hand expression to obtain the left, since completing the square for the left-hand expression may entail a bit more work. The difficulty is not symmetrical. The second kind of proof is known as proof by construction. An example of this is the proof for addition formula. In general, proof by construction tend to be more involved, elaborate, involving diagrams, concepts, and are used to prove more fundamental results. In proving trigonometric identities for this chapter, we shall use direct proof and through algebraic manipulation, prove the statements. That brings us to the last two concepts. In mathematics, equivalence is defined as a relationship existing between two or more expressions. Also, an identity is an equation that is always true for all values in the equation. Now consider this proof where a student is required to prove cosine x equals to sine 90 minus x. By substituting x to be 60 degrees, the student evaluates both of them to be 0.5 and consider the proof complete. Is this acceptable? Unfortunately not. This student had merely established the equivalence for a specific value of x. It is as serious as saying that x plus 2 is equals to x squared because it is true for x equals to 2. In proving trigonometric identities, there are some strategies that can be used. If possible, always start with the side that is visibly more complex. By this, we mean the side that has more terms or contains the three basic trigo ratios. Along the way, think of some definitions or known identities which can be applied at each step. A full list of the identities may be found on page 279 in the textbook. In some instances, if we are stuck halfway, we may work from both sides to a middle point, but please remember to present the final solution from one side to the other. We will now go through some examples. The first may be found on page 267, practice now 17b. Prove 1 plus sine x minus sine square x divided by cosine x to be equals to cosine x plus tangent x. As we can surely tell, the left-hand side is more complicated. So we will write it down and then using the identity that 1 minus sine square x equals to cosine square x, we will replace the two terms, 1 minus sine square x as cosine square x, and further on, distribute the denominator cosine x to both numerators. Simplifying the first term and bringing in the definition for tangent x, we have the right-hand side expression, and therefore the proof is complete. In a second example, which can be found on page 267, practice now 17a, we are to prove cotangent square theta is equals to cosine square theta plus cotangent square theta cosine square theta. As we can tell, the right hand side contains more terms, and therefore we will start with the right hand side. Since we are working towards a single term, we will factorize the common factor cosine square theta, leaving 1 plus cotangent square theta in the bracket. Bringing in an identity which says that 1 plus cotangent square theta is cosecant square theta, and the definition that cosecant square theta is the reciprocal of sine square theta, we will have cosine square theta divided by sine square theta is equal to cotangent square theta. Once again, arriving at the left-hand expression, and the proof is complete. Finally, going back full circle, how do we prove cosine x equals to sine 90 degrees minus x? With the principle that we are always to start with the more complicated expression, the right-hand side sets us up for more potential to begin. So starting from the right-hand side, we will apply the addition formula for sine A minus B and write sine 90 degrees minus x to be sine 90 degrees cosine x minus cosine 90 degrees sine x. Evaluating sine 90 to be 1 and cosine 90 to be 0, we have 1 times cosine x minus 0 times sine x, which gives us cosine x. And now the proof is complete. I hope you have learned some principles on proving trigonometric identities. Happy learning, and see you back in school.